Continuing with graphing functions, today in these notes we're going to talk about slope-intercept form, which is just a way to write an equation that makes it very easy to graph. And now this is specifically a linear function, so we're talking about linear equations graphing a straight line. But this form of equation makes it very simple to graph a line without really doing any work with tables or math or anything like that. So the linear equation y equals mx plus b, this is written in slope-intercept form. Where m is the slope of the line and b is the y-intercept, which is where, again, the graph crosses the y-axis. So this number right here in front of the x is the slope, and the number out here is the y-intercept. So when an equation is written in this form, you can just look at the equation and pick out the slope and pick out the y-intercept, and that is all you need to know to graph the line. So we can write the following equations in slope-intercept form, and then we'll identify the slope and the y-intercept just so we can kind of practice getting these the way they need to be and picking out those important numbers. So the first equation is 2x plus y equals positive 5. So we need to get y by itself. We're going to subtract 2x from both sides here. And this is important that you write the x term first. So you can't actually add these two numbers together because 5 doesn't have an x. So we're just going to be writing y equals, and then you want to write the x term first. The negative 2x comes first, and then the positive 5 plus 5. Okay, so that equation now is in slope-intercept form. The slope here is the number in front of the x, which is negative 2, and the b is the number on the end, which is positive 5. Not b, positive 5. All right, the next one is almost in slope-intercept form. We just need to write the x term first. So it's y equals negative 1/3 x plus 4. So all we had to do was switch those two things. Now the slope is negative 1/3. The y-intercept is 4. Now this equation here, for example C, that's already in slope-intercept form. So y equals negative 5. But the thing about an equation like this is we don't have an x term at all. So there's kind of like this 0x that we don't have to write. And you shouldn't include it even when writing in slope-intercept form because you do want to write the equation as simplified as possible. But when identifying the slope, you do need to know that that slope is going to be 0. And our y-intercept is negative 5. So let's practice actually graphing these. So we have an equation here that's already given to us in slope-intercept form. So here are the steps to graphing these lines. First, we put the y-axis, or the y-intercept on the y-axis. That's the b value. Then we use the slope to find the next point. And then we repeat that process all the way across the graph. And then you can draw the line using a straight edge, and don't forget the arrows on the ends. So let's practice here on example A. We know that negative 2 is the slope, and we know that the intercept is b. So just to make that extra clear, the slope is negative 2 over 1. Remember, slope is rise over run. So it is helpful to have a top number and a bottom number. And if it's a whole number, you know that the denominator, the bottom number, is a 1. And our intercept here is 5. So start with the intercept. Start with the b value because we know where to put that point. It's at 5 on the y-axis. Then we can use the slope, which is down 2, right 1, to find the next point. So from that y-intercept, go down 2 over 1. And then repeat that, down 2 over 1, down 2 over 1. Repeat it until you get to the edge of the graph. Just go as far as you can. Also, go back and go the opposite. You can go up and left. It's just in this case, we're at the edge of the graph already. And then you can draw that line. And if you do as many points as possible, it should be fairly easy to hit all those points. And just draw the arrows and make sure your line goes nice and straight all the way across the graph. So this is the graph of that line. And you see, once your equation is in slope-intercept form, it's pretty straightforward to graph it. Plot the y-intercept, use the slope to find the next point, repeat, and then draw the line. Let's look at example B. We have 5x plus 2y equals 10. Well, first we have to get rid of that 5x. We have to solve for y to get this into slope-intercept form. So that's 2y equals, and write the x term first, negative 5x plus 10. Divide everything by 2 here to get y by itself. So y equals negative 5 over 2x plus 5. There's our equation. We know the slope is negative 5 over 2, and we know the intercept is 5. So again, we have 5 for the intercept. Starts up here at 5, 0, 5 on the y-axis. Slope is negative 5, that's a down 5, and then right 2. So notice when your slope is negative, you're going down to the right. If it was positive, we'd be going up to the right or down to the left. So down 5 over 2, down 5 over 2. These are a little more spread out, but that's okay. Draw your line through all 3 of them. Draw your arrows, and we're good. Now, so that's just kind of the basics of it. Just remember, when you have a positive slope, it'll go up to the right, negative slope, down to the right. These both happen to be negative, and actually pretty similar, but they are different. This one's negative 2, this one's negative 5 over 2. So even though they look almost the same, you can see that the x-intercept ends up being a little different. Just a slight difference in those slopes. Okay, for example C, this one is already in slope-intercept form, so we don't need to do any solving. We can just go straight to graphing. Slope here is 1/2, and the intercept is negative 3. So we'll start down here at negative 3 on the y-axis. Slope is positive 1 over 2. So from that point, we go up 1 over 2, up 1 over 2, up 1 over 2. Now you should also go back to the original point and go backwards. So instead of going up and right, which is how we start, we can also go down and left. So down 1, left 2, and it's still in the same line as the other ones. So as long as you switch both of them, up to down and right to left, you should still be on the same line. And then graph the line. Okay, example D, 3x plus 2y equals 6. We'll start by solving for y, so subtract 3x from both sides of the equal sign. 2y equals negative 3x plus 6. Again, write the x term first. Divide by 2. Leave the fraction on the x, so we get negative 3 over 2x plus 3. 6 divided by 2 is 3. There's the equation. Slope here is negative 3 over 2. That's going to be down 3, right 2. I tend to always put the negative sign, just assign it to the y value on top, just because that makes it consistent. And then our slope, our y-intercept is 3. So start at positive 3 on the y-axis, down 3 over 2, down 3 over 2, down 3 over 2. And also up 3, left 2 is fine as well. And then you can graph that line. Next one, x equals negative 1/2 y equals 1. Or sorry, x minus 1/2 y equals 1. Don't know where that extra equals sign came from. So we're going to subtract x from both sides. Negative 1/2 y equals negative x plus 1. And we need to multiply both sides by the reciprocal here, which is negative 2 over 1. Just make sure everything gets multiplied by negative 2 over 1. So these cancel here, and y equals, well, negative x times negative 2 is positive 2x. And then we have 1 times negative 2, which is negative 2. So our slope is positive 2 over 1, so right, or up to right 1. And then b, our y-intercept is negative 2. So we'll go down 2 and then up 2 over 1. And down 2, left 1 is the opposite from the original point. And there's your nice straight line, just like that. So be careful when you are multiplying, just like when you divide, like when we divided on example D, we divided everything by 2. Here we had to multiply everything by negative 2. So depending on what operation you're doing, just make sure that every number on that side does get multiplied or divided by that number. All right, let's talk about constant equations as well. So constant equations are y equals b or x equals b, where b is any constant. So the y equals b constant equations, these are functions. They graph a horizontal line with 0 slope. But the vertical line, x equals b, is not a function because it's vertical. It doesn't pass the vertical line test, and its slope does not exist, right? It doesn't have a slope. Its slope is undefined. So we're going to graph these equations and state whether or not they are a function. Y equals 4. This is going to be a horizontal line through 4 on the y-axis, just like that. And yes, this is a function. Well, let's just write function. So just remember, y equals 4 means no matter what point you have, y is always going to equal 4. And so however far you go on the x-axis, you'll always go up 4. And so it's just a straight line made up of all the points with a y value of positive 4. X equals -6, just the opposite. Vertical line through -6 on the x-axis. And this is not a function. Because it does not pass the vertical line test. -6 is used an infinite number of times in this function. So it does not pass the vertical line test. -6 is used more than once. All right, y equals 0. So this goes through 0 on the y-axis. So this is a horizontal line right on the x-axis. This is actually the equation for the x-axis. But this is a function because it passes the vertical line test. I think that is it for these notes. So main idea, main point here is slope-intercept form. Get it solved for y, and then identify the slope and the y-intercept. Plot the y-intercept, use the slope to get the next points, and then draw your line. If you happen to have a constant equation, just remember y equals a number is horizontal, x equals a number is vertical, and those are also not functions.